welcome back, guys. To keep this video short, I'm just going to take you straight over to the bench and start my lecture, I guess you call it. Alright, I always wanted to get into anodizing aluminum because everything I make, microphone mode, everything I make is out of aluminum. And I saw this on Amazon and thought it would be pretty cool to just get it. I have, my thread savers, which I've shown everybody. I can't talk today. But I thought this would be really neat. And when it came in, I'm looking at this. Some of these are hard to get out. Beautifully anodized. So this turned me on to the process again. I looked at it a long time ago, but everybody's video is so radically different. I said, no, a bunch of it has to be BS. So forget it for now. I didn't have place for the chemicals, and now you guys have seen the shelf system, emptied the drawers out, 3 drawers, so I have place for all the jars now. It's wonderful, so I'm getting into it here. So this, I wish I could condense it down smaller, but it's kind of nice. I mean, I have thread savers, so I can screw things into it. I can always put a bolt in it and check the nut. But these guys, too, they appear to be CNC made. It's kind of pricey, 32 bucks. But I did put a thread saver on it, put it in a lathe chuck, spun it, and it spins true. So I'm pretty sure I'm just going to keep this set for what it's worth. Put it in one of my empty drawers here. So, alright, so show you guys all the different chemicals and talk about each and every one separately. Okay, I've watched a lot of do-it-yourself at home anodizing videos, and they're all different, and there's a lot of them out there. But first, there's 2 items I want to address. One, what is the electrical conductor you should use for the part that you're going to anodize? And 2, I know after you degrease the part, you're not supposed to touch it. I don't want to waste a whole bunch of nitrile examination gloves so I can touch the part. So I start looking at the videos, and I've seen giant long aluminum screws, copper wire, titanium wire, I mean all kinds of stuff. So I start thinking, okay, I probably should go with titanium wire. Google it, terrible conductor. Great, I've dealt with that with the ground clamp on the welder, so I'm just going to ignore that. Go on Amazon, and I was shocked. 10-foot pure titanium wire was $7-8. In the cart, ordered. Here it is. Nice stuff. Okay, so I'm going to use titanium wire as the conductor to the part. Now, I know you're supposed to have a good electrical connection, maybe, they all say that. So you bend this back and forth, everything you can, and jam it down in the part. Okay, I've got a good electrical connection because it's not moving. And wait a minute, this is a solid hold, so to speak. I can use this now to go from bath to bath to bath, or solution, so I don't have to touch the part now. Perfect. So, okay, that problem is solved. The one curious thing about the wire is after you in the final kind of bath, the anodizing bath, the wire turns this weird blue color. And I'm thinking, okay, this is an insulation, because one guy says, oh yeah, just to get rid of it, stick it back in your acid bath, it'll clean it right up. Well, no, it does not. So I'm trying to clean this up. I've scratched it off, no dice. I've used some brass steel wool, no dice. And since I'm mentioning steel wool, one guy said he used steel wool to clean his part before he went into the anodizing bath, and it screwed up the anodize because miniature or microscopic particles of steel were embedded in his part, and it ruined the anodize. So now I'm paranoid about contamination and using the wrong stuff. So be careful or consider how long you cut this stuff, even though you have 10 foot. This one was the first, didn't realize it, cut it kind of short. But yeah, I did the first part with this side, then flipped it over, did the other part with this side. Now both are blue, so I'm going to just throw that away. This one I cut longer, so I can do one part, then two parts, and then a third part, and then throw this away. So, and it's pretty cheap, 10 foot. It's going to do a lot of parts, but so yeah, all the jars I rinsed thoroughly under steaming hot water, thoroughly dry them, let them sit around for an hour before I even use them, because I'm paranoid about contamination. So okay, I've got the electrical part works. I've successfully done stuff. It holds them. I don't have to touch the part. I'm done. Next up is the question of how do I degrease the part. At videos I've seen everything. ZEP, degreaser, isopropanol. I mean, you name it, they've used it. I was thinking acetone. Why not? That is got to be one of the best degreasers. I mean, you put your finger in it, take it out, and the whole finger's white because all the grease is gone. So, okay, I've got an old can, 30, 40-year-old can of acetone. Let me use it. I'll go to Costco and replace that. It's pretty cheap, 11 bucks for the big can of it. What is it, half gallon, quart? I don't know. But I saw somebody after the acetone had the latex gloves on, wiping the part down with isopropanol, because he thinks that there's some kind of contaminant chemical or something in it that might be left. Granted, this is like a 40, 50-year-old bottle. I don't know what's in today's acetone, so you're on your own whether you want to wipe it down or not. After I'm done with this, I do it for 2 minutes. You make your own judgment call. I know these were big time oiled because some of these have deep threads. This is a 7/16 14, and I know I used cutting fluid, tapping fluid, and it's still down in the threads. When I'm done with this part is spotless. There is no oil on it. I can look at the parts that I've already done, and I look down in the threads, and they are perfectly anodized all the way down to the base of the threads. So, and I got nice jars here for everything. After I successfully did the first one, okay, I don't mind investing a little bit more money into this setup and nice labels and stuff so I don't miss, because I had a hard time figuring out how did I do the first one, what was the times, trying to remember stuff. So now it's all written down. 2 minutes here, 2 minutes there, blah, blah, blah. Okay, so after I pull it out of the acetone from 2 minutes, I just let it air dry. I have dust off, and I'll lightly brush over it, so to speak, to make sure all the acetone is evaporated, because it disappears in a hurry. And I don't put it in the water, distilled water to rinse it or anything. Just air dry it. And I figure that's good enough, and it's been very successful doing that. The next step after acetone and degreasing it, letting it dry, is the videos all show an acid. Muriatic acid, sulfuric acid, battery acid, you name it. I kind of like this, sodium hydroxide. It's fairly cheap on Amazon. It's a powder. It's easy to store, pretty full, and this is going to make a lot of batches, because you begin to wonder how many times can you put a part in here until perhaps it's exhausted, you can't use it anymore. So I've already run 4 parts through this, not this particular batch. I just now, no, I haven't made it yet. This is the old one. So this is run 4 parts. You put a part in there and it foams like crazy. So 2 minutes, NaOH, like I said, sodium hydroxide, it's cheap. The one thing you really have to pay attention to is the concentrations. Make sure, no matter how you do it, you come up with a 2% solution. Do not increase it, do not decrease it. I had just didn't measure and threw some in there, and the first part came out really light. So it's very important that you make the solutions to the correct level, concentration level. 2% means 2 grams per 100 milliliters, so you need to be able to measure it with a beaker or something. To me, grams is very hard to accurately measure, so I'm using my old gunpowder scale, which is grains. And for instance, 2 grams is 62 grains, so I know when I weigh it and put it in here, this is darn close to a 2% solution. How long it lasts, I don't know, but again, this is already done 4 parts, actually 5, because I did this part twice. He's still too light, but I figured out what all the numbers are really supposed to be to make that part, and that part, and they're all the same darkness, so it's great. What else to say about this? I don't think anything else. Again, acetone, air dry, then it goes in this, hangs in it, made a little plastic rod with a hole in it, so I can hang, my part in it. I stick it in the middle too. Too low, and you don't really see the many bubbles coming off the bottom. Too high, same thing, problem. When it comes, I don't know what the purpose of it is. It does give a matte finish when you pull it out, but when you dunk it in the water to rinse it off, matte finish is gone. You're right back to the way your part looked when you first put it in there. So, all right, so that's second step. You're degreased and you got some kind of a finish on it. I found this question very interesting. What do you use to rinse the part off after the acid bath and the anodized pH down bath? Some videos say you're supposed to use deionized water only. Others say distilled water is just fine. You go and research, which I did, deionized water, and it's a chemical electrical process to remove the ions. None of them tell you what they start with for water. Is it tap water? If so, it's got a lot of junk in it, I'm sure. Distilled water is simple. It's steam, condensed, pure water. So I figured, what the heck, it's cheaper. Just use distilled water. And I see a lot of people with a cup after the acid bath and a cup after the anodized bath. What, you don't want to contaminate things? And forget it. 16-ounce jars here. This thing is almost full. There's 4 here, but I did this one twice. I dunked in this bottle 5 times after the acid bath and 5 times after the anodize. No problem. The parts are coming out perfect. I just emptied it for the heck of it and refilled this thing with distilled water for the next 5 uses or whatever. I don't know how long it'll take before you can't really use it. But, when you come out of the acid bath, it's not a gallon of acid around it. It's just a slight film. Dunk it in there, swish it around, it's gone. I have no idea. Well, actually, they're counteracting one another. I just thought of that. Acid and pH down, they should neutralize one another by using the same jar or whatever. So, okay, that's just my 2 cents on what to rinse off with, and do you need separate containers. Next part. Alright, I think that this is the most critical part of anodizing that there is. Let me raise the camera up just a little bit more here. There, perfect. So like I said, pay attention to solutions and your time periods. If you have multiple parts and you want them all to be the same color or darkness. Watched a lot of videos, everything under the sun, including baking soda for this process. Decided one guy used this pH down, which is sodium bisulfate. You need to make a 20% solution. This is one right here. This is an old solution. I think you can only use this stuff once. And I thought anodizing was the process of applying the color. Now, anodizing is an electrochemical process increasing the natural oxide layer of metal. So I started thinking, well, really, can you do steel? Sure enough, YouTube, there's videos on doing steel, and it was a kick because they were using the same chemical as this, sodium hydroxide, but they were holding the part with this. And I'm going, wait a minute. I made one of those contraptions many moons ago. It's just sitting in the back of a drawer. This just keeps getting better, because you'll see in the next video when I'm actually anodizing a part, I'm struggling with trying to put it in the middle of a bath, a solution. So this has a home now. Perfect. Okay, back to this stuff. Now you need to do the 20% sodium bisulfate. Amazon, they sell you a ton of it here, huge bag. And I'm going to use aluminum foil as the negative side of the power supply, and then the titanium as the plus side. Suspend it in the middle. You can't have it too low or too high. It doesn't come out right. It goes for 1 hour. I started, they always say, oh yes, you need 1 amp or this. No, I don't get that. So once I got the solution correct at 20%, the current went way up. So I start low, 30 milliamps for 15-20 minutes, and then you'll have to play your own game. Eventually I wind up at 90 milliamps. I don't even go up to an amp. Tons of bubbles come off the aluminum foil, nothing on the part. And I think, yeah, you're creating an oxide layer. Well, that oxide layer is on the part and on the aluminum foil. The aluminum foil comes with a dull side and a shiny side. I tried the dull side, didn't work as good out. So I'm always using the shiny side out. I want that against the wall, curved. Want the part in the middle floating, and then apply the plus to it, and you just go for an hour. When it's done, yeah, your titanium wire, which is steel, is anodized blue. I just watched that one video, and that's what that is, and it doesn't come off. I think I already said anodizing doesn't come off of these parts. I screwed this one up. Tried Scotch-Brite, tried sandpaper, everything doesn't come off. You have to reface the whole part if you want to try it again. I had the solution wrong, so the part's really light on here. Once you're done, I think the solution's exhausted. I know the aluminum foil is anodized. It has an oxide layer to it. Your part is anodized, has an oxide layer to it. And I suspect the thicker the layer, the more of the dye it will absorb. This is really light because I don't think I had the solution strong enough. Was just guessing at a bunch of things, learning. So this I'm going to do, I already have for each one of these parts. I've tossed this, cleaned the beaker out big time, dried it, and created a new solution of it. Because like I said, this thing is full way up to here. And I've done 5 times. I did this guy twice. I barely even touched this bag. I've got to figure out some container to put this in because it's really hard to scoop it out. And I'm at 140 milliliters and 280 grains, again, not grams, grains, in this bath to do this stuff with. So this is ready to go in the trash because this just did this part right here. Anything else? Yeah, when you're 140 milliliters, when you dump this stuff in there, it's now 150. It's a lot. So I'll put the distilled water in there, then I'll put in the stuff, and you stir it forever and then let it sit because it's all foggy. Walk away, come back, it's cleared up, but there's still a pile on the bottom. Stir it some more. I just use a wood stick, which you'll see. And then I can put the aluminum in there in the part and start the process for 1 hour. I don't think there's anything else to say on this one. Yeah, when it comes out, it goes in the distilled water. It gets rinsed really well, and I can leave it in the water for as long as I want until I'm ready for the dye. The last is Amazon does carry it, $18, $19. A professional anodizing dye. Bring it over out here. I need to find a nice jar that matches these for this and put the label on it. All the videos I saw, you cannot see through the jar or solution. This is supposed to make a gallon. I originally just kind of did a couple of eyedropper squirts. It was in there, you could see through it, and it didn't do a good job at all. So I have now in this is probably 250 milliliters. Half this bottle is in there. Like I said, all the videos, you cannot see through the fluid. Even if you're going to use the RIT clothing dye, dump it in there. So I have half left, and putting it in here, 4 minutes is what I've done these parts with. You pull it out early and you can kind of see, yeah, it's not really dark enough, and you put it back in there. Heads up, if you take it out and you let it dry, you cannot put it back in. It will not affect it. If it's light, it's going to stay light. When it's done, I pull it out, I dab it with a paper towel so I can kind of see the darkness of the actual aluminum. If it looks good, then I'll roll it. Now just dab on a paper towel, get all the fluid off of it, let it sit. I'll blow the center out with the, dust off to get it out of the threads. Then I just let it sit and air dry, and once it's dry, then I can pick it up and handle it, and it's beautiful. I'm not sure if I said yet, if you're doing multiple parts, your finish has to look the same before you do it, because you can see right through the anodize. If your parts don't look the same, they're not going to look the same after you dye them. So that's kind of in conclusion. So I guess the next video I'll show live actually doing all of this stuff.